Welcome to this session. So, in this session, we are actually starting our electromagnetic theory. So, till now we discussed many tools which are required for understanding our electromagnetic theory, like vectors, coordinate systems, differential calculus, integral calculus, etc. All these tools will very much useful in understanding our electromagnetic theory in different ways. So, now what we are doing is we are actually entering into the electromagnetic theory subject starting from electrostatics. So, this electromagnetic theory was entirely divided as different parts like electrostatics, magnetostatics, Maxwell's equations which are for time varying fields, boundary conditions, transmission lines, antenna theory, microwave engineering, etc. So, many fields are there. Now, for all these things the basics are electrostatics and magnetostatics. We will start our discussion with electrostatics. What are electrostatics? As we know, the name itself indicating is static. A static charge will be there. So, this entire electrostatics will revolve around a static charge. That is a charge which is kept at rest location, at which at some location the charge was unmoved. It is kept at rest. So, we are discussing many aspects which are related to the charge when it is kept at rest. So, what are different phenomena you can observe when a charge is kept at rest? That what we are going to observe in our electrostatics. Before that, we will define what are different types of charges we have. So, apart from the charge what we are discussing, we have many types of practical charges. So, we need to learn about all those charges initially. So, we will start our discussion with types of charges. So, what are different types of charges we have? We have a point charge, line charge, surface charge, and volume charge. So, these are different types of charges what we come across through this entire course. That what is point charge? We need to learn how a point charge can be observed and what is the application of that point charge. And what is a line charge? Why this will call as a line charge? This will be called as a line charge. And what is surface charge? Why it will be called as a surface charge and where it will be used and where we can observe that one and where a volume charge can be observed and what are the parameters which are involved with that volume charge. We will discuss about that. The first come across this point charge. So, what is this point charge? The name itself indicating, just you remember the name. If you remember the name, then obviously we can get what is that particular type of charge. Point charge, the name itself indicating just it is a point. When it is a point and where it is a point? Point means infinitesimally small volume. Whenever you are considering a charge, the volume of that particular charge is infinitesimally small. That when compared with the surrounding dimensions of that one, the volume is infinitesimally small. That what we can say. So, we need to compare the dimension of that particular point charge with its surroundings. Let us take an example. If you are considering a charge which is of our cricket ball size, then if you are observing this cricket ball of charge from 100-meter distance, then obviously it looks like a point charge. The dimension of our charge what we are considering is about 6 to 7 centimeter. So, when compared with this distance what we are observing, this 6 to 7 centimeter is very small. That is why this can be treated as a point charge. In another example, if you take a charge of this much size, and if you are observing this charge from 200-kilometer distance, so when compared with our charge, the distance what we are observing is very high. So, when compared with its distance point of observation, the distance between the charge and point of observation, you can treat this charge of this much size as point charge. So, irrespective of the physical dimension of the charge, clearly remember, irrespective of the physical dimension of the charge, if the volume is small when compared with its dimensions, we can treat that one as a point charge. Now, what are the point charge representation? Every point charge can be represented with Q. So, the symbol for point charge is just Q and the units are coulombs. So, whenever we are taking a charge, remember this is the basic charge, that the charge will be represented with a capital letter Q and the units are coulombs. That what we need to remember. Next, come to the line charge. Now the name itself indicating, once again remember the name itself indicating a charge which is distributed on a line. So whenever we have a charge and that is uniformly distributed over a line, irrespective of the shape of that line, we are considering it. So if it is uniformly distributed on a line, then it is said to be a line charge. Now observe, here I am considering positive charge, that this is the line what I am taking. On that line, the charge was uniformly distributed on that line. So here clearly this particular type of charge is said to be line charge. Now how to calculate the total charge for a given line charge? So if you want to calculate the total charge for a given line charge, we need to observe how the charge was distributed over that line. So as I said, it is uniformly distributed. So how that was defined? Now calculate the total charge given per differential length dl. So what we are doing is we are taking a small length, differential length dl, and for the differential length, what is the amount of that charge we are calculating? That is charge per given length. That what is the parameter we are observing? That charge per given length is called as line charge density. So here clearly what we have to do is, for observation of the line charge, always we are supposed to consider line charge density, the charge per given length. It is denoted with a symbol rho suffix L. The line charge density, L stands for line. This rho is the charge density, line charge density. As I said, how it is defined? The total charge what we are observing per given differential length. So dq by dl, the differential length is very small what we are considering. That's why it is limit delta L tends to 0. So that line charge density is simply limit delta L tends to 0, the charge per given length. Now observe the units. See, in our previous case the units are just coulomb. Now here what are the units for line charge density? Since we are saying that it is a charge density, the units are coulomb per meter. So the charge per given length. Next, observe the surface charge. If you are taking this surface charge, once again the name itself indicating the charge which is uniformly distributed on a surface. Here whatever it may be the surface may be the open surface or the surface may be the closed surface. What we are doing is we are considering that particular charge on a surface. So here we need to represent again this charge, the uniform representation of the charge on a surface, like this. Here also I am considering the positive charge. This positive charge was uniformly distributed on that surface. To observe the charge, once again we require one more parameter. For that, what we do is we will take the differential area. For this differential area, how much charge is there? That is the charge which is distributed per differential area. So we need to take another parameter called as surface charge density. Since it is the charge which is on surface, a surface charge density will be there. How it is defined? The charge which was observed per differential surface, that is delta q by delta s. The differential surface what we are considering is infinitesimally small. That's why here we need to take the limit delta s tends to 0. So line charge density is limit delta L tends to 0 dq by dl. Surface charge density is limit delta s tends to 0 dq by ds, or delta q by delta s, the amount of charge what we are observing for differential surface. Now observe the units here. Q, coulomb per the surface area, it's meter square. So clearly this is another type of charge that what we can observe now. Now we are moving to the third type of charge. What we have is volume charge. Now the name itself once again indicating for any given volume the charge was uniformly distributed. Here how the charge was distributed? Within that particular volume what we are considering. It is not on the surface, it is not along the line. So within that volume the charge was uniformly distributed. So consider a volume, it's a three-dimensional one. So on that volume, it's within that volume the charge was uniformly distributed. Now whenever you are supposed to observe this particular volume charge, you are supposed to take the volume charge density. Now the volume charge density, how it was defined? The total charge per given volume. For that what we are doing is we are taking a differential volume dV and we are calculating how much charge is there per the differential volume. So the volume charge density can be represented with symbol rho v. Volume charge density rho v. So rho v is equals to the amount of charge what we have per given differential volume. Now once again, so this differential volume is an infinitesimal volume that what we are considering. Since it is infinitesimal volume, take limit delta v tends to 0. So the volume charge density is limit delta v tends to 0, delta q by delta v. Right? Now what are the units here? Charge units are coulomb. The volume units are meter cube. So apart from the point charge, we can observe different types of charges. Just observe here, point charge is a simple point charge, what we are considering as Q. But a line charge is not simple Q. Instead of Q, what we are considering is the line charge density. Using this line charge density, we can calculate the Q. We will discuss that one also. Using this surface charge density, we can calculate the total charge on that surface. Using the volume charge density, we can calculate the total charge within that particular volume. So before that, just you remember these quantities. So in practical cases, we always come across with these 4 types of charges only. A charge may be as point charge for analysis purpose, or practically that may be along a line, or practically that may be along a surface, on a surface, or within that particular volume. Now how to obtain the total charge when we have all these charge densities? When we have a line charge density, how to obtain the total charge? When we have surface charge density, how to obtain that? When we have volume charge density, how to obtain the total charge? Just remember, whenever we have densities, if you multiply density with the corresponding quantity which is in the denominator, you will get the total charge. So line charge density is multiplied with length, we will get total charge. Surface charge density will be multiplied with its area, we will get total charge. Volume charge density multiplied with its volume, what we will get is total charge. Since we are considering a differential elements here, we need to take the integration of those differential elements throughout the course. So the integration of line charge with respect to the line, the integration of surface charge with respect to the surface, the integration of volume charge with respect to the volume will give us total charge. Now we will write them as equation. Now observe how to obtain the total charge per given charge density. Line charge is given to us. The line charge density is the most useful quantity to obtain the total charge. We need to integrate this line charge with respect to the differential length what we have to obtain total charge. So the total charge can be obtained by integrating the line charge density along the line what we are considering. In the same way, the total charge Q can be obtained by integrating our surface charge density rho s over the surface ds. By integrating the volume charge density, we will get the total charge over the volume. So here clearly the same charge can be obtained from its line charge if there is a line, and surface charge if there is a surface, and volume charge if the charge is within that particular volume. And clearly remember, in all these cases, the line charge, surface charge and volume charge, the charge was uniformly distributed. That what we will assume for the entire course. That is, for every location within that particular region what we are considering, along the line or surface, on surface, or within that particular volume, irrespective of the location where what we are considering, the charge is uniformly distributed. It is same, right? If it is not uniformly distributed, so this will be varied. We are not supposed to calculate like this. So what we do is we will assume throughout the entire course this is a uniformly distributed charge. So for this line, surface and volume.